Hi viewers, in this video we are going to discuss about pagination and sorting using JPA. Myself Shankar, I'm working as assistant professor in the Department of Computer Science and Engineering. Let's see about today's topic called pagination and sorting using JPA. In JPA, Java Persistence API, pagination and sorting are crucial features when dealing with large data sets retrieved from a database. So, which means that when we are using a large database, which consists of very large data sets, if we want to retrieve our data from the database, it's very difficult because the database contains very huge amount of data. In such a case, if we are using pagination, we can retrieve some subset of data from the entire database, which helps you to retrieve some portion of data from the entire database. And also the sorting can help you to retrieve the data in some such a type of an order, whether it is ascending or descending like. So it helps us to retrieve our data in a easiest way from the large set of data sets. Also, the pagination allows to fetch a subset of data, typically to enhance performance by reducing the amount of data transferred and displayed at once. So as I said already, what is sorting? So the sorting, on the other hand, enables ordering query results based on the specified criteria such as ascending or descending order of columns. And let's see small differences between the pagination and sorting. So first we'll see what is pagination. Pagination involves dividing a query results into manageable chunks or pages to improve performance and user experience. Whereas sorting is arranges query results in a specified order, such as ascending or descending, based on one or more attributes of the entities. For pagination, it's specifying a starting point and maximum number of results for developers can control which subset of data to retrieve and display. Whereas in sorting, it can be achieved using order by class in JPQL, which means Java Persistence Query Language queries, or through the Criteria Query API in JPI. And let's see the reasons why we are using pagination and sorting. We should use the pagination and sorting techniques for the following reasons. So very few reasons I have specified here. The first one, smallest results are easier to process by both server and client. Also, if we have large set of results, it would require more resources like a CPU usage, memory usage, networks, and so on. Also, the sorted results bring order to the system, and sorting makes it possible to prioritize the items. And let's see the step-by-step guide on the pagination and sorting in Spring Boot REST API. So first step, we have to set up the Spring Boot application. So initially, we have to ensure uh, whether we have the necessary dependencies in our pond.xml files or not. So actually the tag which encloses dependencies encloses many dependencies which are required for our projects. So under this dependencies tag, we have a tag called dependency which encloses whatever the dependency we need for our projects. So we need to specify the every individual dependencies with the tag called dependency. So inside the dependency, we need to specify two important tag called group ID and artifact ID. So already I told you that the tag called dependency, it tells Maven to download and include the library automatically. Maven means it is a build automation and dependency management tool. So let's see the tag called group ID. What is group ID? Group ID identifies the organization or project that provides the dependencies. So here in this example, we have specified the group ID as org.springframework.boot, which means that it refers to the Spring Boot projects. And the second tag called artifact ID, which specify the particular Spring Boot module what we want. So in this case, it has specified that Spring Boot Starter Data JPA, which means that it enables the Spring Data JPA for database operations like saving, updating, and retrieving data using entities and repository. In the next second dependency, so the group ID is same, which because we are working under Spring Boot framework, but we need another dependency called Spring Boot Starter Web. So this dependency artifact ID dependency allows building RESTful web services and handling HTTP requests. And the next we have used third basic dependency, that is called com.h2 database. So here the artifact ID is H2, which means that it provides an in-memory database used mainly for development and testing purpose. So here the scope is runtime, which means that it automatically running at runtimes. So here altogether these dependencies let you create full thread applications quickly, which means that create, read, update, and delete. Also, it connect to a database, managing entities, and expose APIs via web interfaces. All dependencies are managed automatically by Spring Boot, reducing manual configuration. And let's see one simple example how we are creating this pagination and sorting. So first, we needed to have data sets, which means that data. So the data sets will be stored like a table. So we need to create a table. So in this Spring Boot application, we need not call we need not to call the word called a table. So here we are calling it as an entity. So first we need to create an entity which contains some set of data. Right, so here defining an entity class that maps to a database table. So in this example, we are creating an entity called product. So in the right hand side, we have an annotation called at entity, which helps you to create an entity in Spring Boot applications. Next, we have public class product. So here the product we will not consider as a class because we have annotated this class as an entity. So it will be created as entity, not in a class. And inside the product class, we have at ID, which means that the following attribute have been considered as primary key. So wherever we have annotated any attribute as at ID, which will be considered as primary key. And also we have annotated another annotation called at generated value, which means that we are assigning auto generated value. So also inside auto generated value, we have given that strategy equal to generation type dot identity, which helps you to create an unique values. So next, the attribute called created called as long ID. Even though you have assigned the ID as long, it's automatically assigned as integer data type because we have assigned an auto-generated value. So whenever we have assigning auto-generated value, automatically the value has been generated like 1, 2, 3 unique values, which is in the type of integer. So also the attribute has been have been annotated with at ID. So the long attribute will be considered as integer because of auto generated value, and we also assign it as at id, which means that this id will be a primary key for this entity. And the second attribute name is name, which will be declared in the type of string, but we have not annotated any annotation for name. Also we have another attribute called price is also not annotated with any annotations. Then the type of price is double. So after that, we need to write the code called getter and setters. I have not specified any getter and setters here. So you need to construct here getter and setters, constructors, empty constructor, everything in inside the class called product. And once the class is created, we need to create a repository. So for creating a repository interface, it extends a JPA repository to gain access to pagination and sorting capabilities. For that, we need to include two packages mainly. The first one is org.springframework.data.jpa.repository.jpa repository. And the second package is org.springframework.stereotype.repository. So here we need to annotate the interface called at repository to indicate the repository file. And here we have created an interface called the product repository, which extends from the JPA repository. So here we have added the entity called product as a type of list, which returns say long. And next, we need to create a service layer which helps you to handle the business logic. So the file has been annotated with that service annotation. So here we have created a class called product service. And next we have annotated inside the product service class, we have annotated the repository object as auto-wired. And next we have creating a method called get products, which will be written as the pageable as a list of product entity. And also this get products method have an argument called pageable as an object, and it returns the all repository files finding all types of pageable objects. And here next we need to create a controller file. So create a controller to handle incoming HTTP request and use the service to fetch the paginated and sorted data. So here we need to annotate the class called at rest controller. Also we are having the at request mapping for getting the data, and the endpoint name is the endpoint name is products. So we have created the controller class called product controller. So here we have annotated auto-wired for service layer. That is private product service. Product service is the objects. So here we have used at get mapping annotation for getting the data. Public page, and we have passed the product as a list. And here we have defined the method called get products. So inside we have defined the parameters like at pageable default. So here we are mentioning the default size and sorting names. So here by default it retrieves 10 record. That's why we have specified here size equal to 10 and sort equal to name. Next, pageable is an objects. It returns the product service get products of pageable. So all the data has been retrieved. So automatically get products of pageable calls the um, method which we have defined under create service. So get products pageable object. So it returns all the data and it will be returned here. So at max by default it returns 10 records, because in get products at pageable default size we have mentioned as 10. Next, we need to concentrate about the configuration steps. Optionally, you can configure some default pagination settings in the application.properties file. So here in the left-hand side, we have specified that string.data.web.pageable.default page size is equal to 10, which means that by default we are retrieving 10 records. And next, spring.data.web.pageable.max page size is equal to 50, which means that the data by default it retrieves 10. At max, it retrieves only 50 records. Some of the example has been given it on the right hand side. We can test the API using different query parameters for pagination and sorting. So if initially in the address bar we are giving get slash product, which means that product is an endpoint name. So I'll show here. So here you just look at once at request mapping products. So this is the endpoint name that we are giving here. If we are giving here products, it retrieves by default 10 record, because in the coding we have mentioned by default size is equal to 10. So which means that by default it retrieves 10 records. We just to see the second one, custom page size, which means that we can assign custom page request also. Instead giving the get slash products, if I given get is a method which helps you to retrieve the records, right? So get slash products, after that question mark page equal to 0 and size equal to 5, which means that it retrieves 5 records, not 10 records, because here we are specifying the size. If we have not specified the size, it will record by default 10 records. When we are specifying the size, that many records will be displayed. So that is custom page size. And the next, sorting by the price. So as we so far we have discussed that pagination. So next, sorting. So sorting by price. So here get is the method name which helps you to retrieve the record, and we are specifying the endpoint name as product. Sort equal to price comma ASC, which means that it retrieves 10 records, because already we have specified that by default it retrieves 10 records. Sorting is applied based on the attribute called price in ascending order. So price is sorted based on the ascending order. And next, last The example is pagination and sorting. So far we have discussed pagination separately, sorting separately. Now we are applying pagination as well as sorting. So get is a method and endpoint name is product. So it retrieves records from the product entity. So here page equal to 1, size equal to 5. So first page it displays 5 records and sort equal to price comma descending order, which means that in this request it retrieved 5 record as a page 1, that also sorted based on the price in descending order. So this is what this example as represents. I thank you all for watching this lecture so far. I thank you once again. Thank you.